Hello everyone, welcome to the channel. We have a nice equation to be solved for x. We have x to the power of ln 3 plus x to the power of ln 6 is equal to x to the power of ln 12. Now my friends, let me begin with reminding you a rule with logs. We have a to the power of log base b of c, and we can write this as c to the power of log base b of a. This is a rule in logs. Let's use this to make this equation look like an exponential equation. We can interchange the positions of x and these numbers in ln. We can write this as 3 to the power of ln x. The second one, 6 to the power of ln x, and the right hand side as 12 to the power of ln x. This is better since now we can solve this like an exponential equation. Let me call this ln x some t. Just let this ln x be some t. Then we have 3 to the power of t plus 6 to the power of t is equal to 12 to the power of t. Now my friends, since 6 is 3 times 2 and 12 is 3 times 4, we can write this as 3 to the power of t plus 3 to the power of t times 2 to the power of t, and the right hand side becomes 3 to the power of t times 4 to the power of t. And if we factor out 3 to the power of t in the left hand side, we will have 1 plus 2 to the power of t. This is equal to 3 to the power of t times 4 to the power of t. Now, my friends, since 3 to the power of t cannot be equal to 0, the exponential function with base 3 cannot be equal to 0. We can cancel this term and have this 1 plus 2 to the power of t is equal to 4 to the power of t. And this is another exponential equation. You may have seen this. Now let's again use a substitution and call this 2 to the power of t as u. Then we will have 1 plus 2 to the power of t is u, and 4 to the power of 2, t is equal to 2 squared to the power of t, also 2 to the power of t all squared, so this is equal to u squared. Having everything on the same side, we can write this as u squared minus u minus 1 is equal to 0, and using the quadratic formula, we can find u as negative b, which is negative 1 plus 1 plus minus the square root of b squared, which is negative 1 squared, is equal to 1 minus 4 times a times c. This becomes 5. You can calculate by yourself, divided by 2 times a, which is 2. These solutions are found for u, but remember u is 2 to the power of t, so we have 2 to the power of t is equal to 1 plus root 5 divided by 2, which is also the golden ratio phi, or 2 to the power of t is equal to 1 minus root 5 divided by 2. From the first one, we can just take the log of base 2 and write t is equal to log base 2 of the golden ratio phi. But the second one is a negative number, and we have no real solutions from this part, since the exponential function cannot be equal to a negative value. Now, finally, t was for ln x, remember. T is equal to ln x. So we have ln x is equal to log 2 of the golden ratio, then x is equal to e to the power of log base 2 of the golden ratio. And this is the final result. This is the only root that satisfies our equation. Thank you for watching and see you in the next videos.